Application now. Consider the compound amount PT written as 18,000 times e to the 0.02 t. We want to determine the rate of change of this compound amount. So basically we are taking derivative. So this is your given function. So when you take the derivative, this is here e to the ax type. So then the derivative, you just keep your constant 18,000, and then the derivative of e to the 0.02 t is just like this. You multiply with a value, which is 0.02. And after simplification, you get 360 e to the 0.02 t. And this amount you can see is positive, so that's why I call it increasing. The rate is increasing. Next, we are taking the value of a car, which is given as 18,000 times e to the negative 0.02 t in US dollars. So we want to determine the rate of change after 5 years. So first let us take the derivative and see what happens. This is your function here. So the derivative, as usual, the multiple constant, you leave it here. E to the x will be e to the x, or e to the t, whatever it is. And then the derivative of this one, or you can identify what is your a, multiply with it. And then simplify, you get this. And as you see, e to the any value you have is positive, but you have a negative in front. So the whole result is negative, meaning is the rate of change is going down. That means the rate of change of value of the car is decreasing. Negative, meaning is the value is decreasing. After 5 years, the value of the car decreases by, you just replace t by 5 and simplify. $325.74 approximately. Higher order derivatives and applications. So first we consider a function f of x is 6x to the 3 plus 63x squared minus 144x plus 8. And we want to do the couple of things. We'll find the first derivative and the second derivative. So our first derivative is f prime x, or you can say dy dx. Use the power rule. So you are getting 6 times 3x squared, that gives you 18x squared, plus 63 times 2x, which is 126x, minus 144. And then the second derivative goes from the first derivative. So that gives me 18 times 2x is 36x, and then 126. And then free constant, in this case 144, approaches 0, or goes to 0. Is a 0 multiple. So we got our first derivative, second derivative. And next we are saying now solve f prime x equals 0 and f double prime x equals 0. So we're following all the steps. When f prime x is 0, so I have the quadratic to simplify. So first we factor out 18, and then we get x squared plus 7x minus 8 equals 0. Factor it. So you get x plus 8 times x minus 1 equals 0. We get x equals negative 8 and x equals 1. And since first derivative is giving us 0, and these values are in the domain, so these are critical numbers. So our critical numbers are x equals negative 8 and x equals 1. Next we do the solution for second derivative equals 0. So you have 36x plus 126 is 0. So then definitely you can factor out, or you can just subtract 126 both sides and divide by 36. Either way, you will get x equals negative 3.5. Okay, so we'll see what we'll be doing with these values. Number line test we'll be using for max mean and concavity. So for max mean, we'll be checking the sign of first derivative, and for concavity, we'll be checking the values for second derivative. All right. So number line test for f prime x is 0. So we take a number line and place the critical values, negative 8 and 1. Now we'll be taking some test points. Left side of negative 8, say negative 9. In between negative 8 and 1, say 0. And after 1 is a 2. Next, we'll be checking the sign of first derivative. So if you plug x equals negative 9 in the first derivative things here, you see x plus 8 times x minus 1. So you get negative sign for the first one and the second one. So altogether you get a plus sign. Of course, you can graph the first derivative and check the sign of first derivative at the test points. So you get positive, and then 0 gives you negative, and then 2 gives you again positive. So what we say about the graph? F is increasing in the first part, then it decreases, then increases. Now we can say the function f of x increases on negative infinity to negative 8 and from 1 to infinity. And it decreases on negative 8 to 1. So what do we get? We have maximum at x equals negative 8 and minimum at 1. So then we list here. Minimum, f1 gives me 67 negative. As a point, you can say 1 comma negative 67. And the maximum at negative 8, which is 2120. And as a point, you can write negative 8 comma 2120. Next, we'll go for second derivative test to check the concavity and inflection point. So number line test for second derivative equals 0. So we take the number line and place the value that we got from the second derivative equals 0. And this is the candidate for concavity. Again, we need to take the test points. So negative 4 on left side of negative 3.5, and right side we can take 0. Now we check the sign of second derivative. So second derivative, as you remember here, 18 times 2x plus 7. So when you plug negative 4 for x, you can see clearly this answer is negative. So we list negative. And when you plug x equals 0, it is positive. Now what can we say about the derivative? The derivative is decreasing on the left side of 3.5 with a negative sign, and the right hand side goes to positive, means up, increasing. And we write the derivative f prime x negative, meaning it decreases on second derivative negative there. So decreases on negative infinity to negative 3.5 and increases on negative 3.5 to infinity. Looking at the second derivative, we can see the change of sign, negative to positive. That means we have change of concavity. So then the function on the left side of negative 3.5 decreases. We call it concave down. And on the right hand side is concave up. So then we can say x equals negative 3.5 is the point of inflection. So inflection point is, you can list this one as a negative 3.5 and then 1026.5. Now we'll see all this in the graph, as you see here. So we see our relative maximum at negative 8, relative minimum at 1, and the inflection point at negative 3.5.